to week 4. This week we're going to take a look at the concept of inflation. And aside from talking about the definitions, there are several calculations in this chapter which you might find confusing or have questions about. And so I wanted to take some time to review all of those calculations. So the first thing we're going to do is just define inflation. So inflation is a general and ongoing rise in the level of prices in an economy. So because we're looking at macroeconomics, we're not going to just look at the price of one good or one service. We're talking about general price increases. So for a basket of goods and services. We see this all the time. Prices change. You'll notice that prices change at your favorite restaurants. They change at the pump when you go to pay gas. And you find that they tend to increase. Now, sometimes they can decrease too, but generally, on average, the prices of all goods and services that you're purchasing tend to increase. So the first calculation that I want to take a look at, and again, I'm not going to go through all of the material in this chapter. I'm just going to be taking a look at the calculations. So remember to review the rest of the chapter on your own for the quiz and also for our final exam. But the first thing I want to do is take a look at how do we look at price changes for baskets of goods and services. So when we talk about the Consumer Price Index, which is an index of the typical consumption for an urban household, so the basket of goods and services that an urban household would consume, we're going to be looking at the price changes on an annual basis for that household and see, well, how much did the prices of all the goods and services that I bought this year change in comparison to last year? And we have to know how to calculate that basket of goods and services. And so we've come up with a hypothetical example here. So in our basket, we only have four different goods. We have a bike, ice cream cone, dish detergent, and a college textbook. So obviously this isn't representative of what you would actually be buying on an annual basis, but the idea is let's just figure out how to calculate the basket. And so we don't want to include everything, as it would be sort of laborious to include all of the different goods and services that we're buying and know all of the prices year over year. But that's exactly what the Bureau of Labor Statistics is doing when they calculate the Consumer Price Index. So we have our different goods and services, and we have the different years that we're going to look at the prices for, and then we can see how much inflation there is between one time period and the next. So in 1990, the cost of a bike was $50, and these are just figures I've made up. And again, in 2015, I calculated the cost of a college textbook to be $350. And so what we want to do is know the prices for each good or service in each time period, and then sum those items. So 50 plus 125 plus $3 plus 100 is going to give us $154.25 for the basket, the hypothetical basket in 1990. When we sum the prices of those goods in 2015, the prices of the goods and services are $509, and in 2000 they're $331.25. So if we want to calculate inflation for these goods and services, what we're going to do is look at what is the value of the goods and services in the year, the final year, minus the value of the goods and services in an original year, divided by that original year times 100 will give us the percentage change. So that would basically be the amount of inflation for the goods and services. And so I would do this, for example, if we want to look at the inflation between 2000 and 1990. So what was the percentage rise in prices between 1990 and the year 2000? We would say the level in 2000 minus the level in 1990 divided by the level in 1990 times 100. And so if we do the math out, it's 331.25 minus 154.25 over 154.25 times 100. And so let's get our calculator out. 331.25 minus 154.25 divided by 154.25 times 100. And so we see that there was actually 100% inflation, so 114.74% inflation. And so that is how we would interpret that number. And it makes sense because roughly 154 times 2 is about 300. So we know that the value of the goods and services doubled in those 10 years. And we can actually quantify it by subtracting one basket from the other and dividing it by that original basket and multiplying by 100. So there was 114.74% inflation, or growth in prices. And so the next thing we might need to do is, aside from calculating the increase in price, so here's really what the question is, the increase in price for a basket of goods or services, we might want to calculate an index value based on the basket of goods and services. And so that's what the CPI is. The Consumer Price Index is looking at, well, not just what is the value of those goods and services, but we're indexing it. And then when we look at the index year over year, then we can measure the amount of inflation. So let's say that 2000 is the base year, and therefore we'll define 2000 as having a base year of 100. So if the year 2000 has a base year of 100, and always the base year is going to be denominated in 100, how would we find the index value for the year 1990? So the way we want to do this is to just do some simple cross multiplication. So in the year 2000, the total value of the goods and services in our basket was $331.25. Relative to a base year of 100, in the year 1990, which was 10 years earlier, we would have seen that that basket of goods and services was 154. But we don't know the index level because we have to calculate it. So using some basic cross multiplication, 100 times 154 equals 331.25 times x. When we multiply 100 times 154, we come up with our index level of 46.49. Now, to be able to see how much inflation there was between that time period, again, we could have just looked at the value of the basket and said 331 minus 154 over 154 times 100 to come up with the inflation. But we can also use the index level, and so this is how we calculate the index. And let's make sure that our math was right. So we're not just going to subtract 46.49, which is the index level. Let's put this down. Index level in 1990. We're not just going to subtract this from the index level so we have index level in 2000 minus index level in 1990. We have to then divide by that original index value to get the percentage change in the index. If we subtract, we're not going to be correct. And then we multiply it by 100 to come up with the percentage change. So 100 minus 46.49 divided by 46.49 gives us roughly and so absent a little bit of rounding errors that we have here, 115, 115% inflation is essentially what we had up here, or 115% inflation. So it's going to yield the same, obviously the same amount of inflation we'll be able to see, but what we're doing here is, in the first instance, we're just looking at how much inflation there is between one year and the next. In the second, we're actually calculating an index value. And so that might be something I would ask you to do if given a basket of goods and services. Can you calculate the index value if we assign a base year in a certain year? Okay, and so this brings us again to what I've been discussing, which is the Consumer Price Index. So the Consumer Price Index is a measure of inflation calculated by U.S. government statisticians at statisticians at the Bureau of Labor Statistics, and it's based on the price level of a basket of goods and services that represents the purchases of the average consumer. So this information is really important to us for many, many reasons. We index a lot of things in one way or another to CPI, and by doing that, we can adjust wages on an annual basis so that they reflect changes in prices. If, for example, you're making $40,000 a year, if you make $40,000 next year and we have 3% inflation, then your real income is actually much lower than you think it is. So the CPI is very, very useful tool. It tells us a lot about what's going on with the average prices that are affecting the average consumer. So that kind of brings us to the idea of nominal versus real GDP. Now in chapter 8, we're going to talk about GDP in much greater detail, but I do want you to be able to step aside here and calculate real GDP if I give you the nominal GDP and what is called the GDP deflator. So recall, GDP is the total expenditures on final goods and services in an economy during a certain period of time. Otherwise, from the expenditure model calculation, we get consumption plus investment plus government expenditures plus net exports, and that will also yield our GDP. So if we have GDP in nominal billions of dollars, so this being $12,000 billion or 12 trillion, and this being $15,000 billion or 15 trillion, we can use our GDP deflator, which is an index that provides information about the changes in GDP year over year, but not the changes in the growth of GDP, just the changes in the prices. So our 2005 year would have been our base year. In the base year, our nominal GDP of $12,623 billion is equal to the real GDP of $12,623 billion. But we see that the index actually rose by 11%. The GDP deflator increased by 11% from 2005 to 2010. So this $14,527 billion figure is we're not able to compare the two to really see how much growth in GDP we have, because we obviously have changes in prices occurring at the same time. So how do we solve for the real GDP, and then how do we see how much growth? So there's really, in this, when we're looking at nominal versus real GDP, we're asking ourselves two questions. How do we calculate real GDP given nominal? And how do we calculate growth? And we'll be using real GDP to do that, because nominal is going to have the impact of price changes in it. Okay, so let's look at our example. How about we compare the year 2011 to the year 2005? So we want to see how much real GDP growth there was between 2011 and 2005. The first thing we need to do is to get nominal GDP in 2011 back into 2005 dollars. So because there is inflation, because prices are generally increasing, a dollar today is not the same as a dollar tomorrow or as a dollar 10 or 15 years ago. So we need to account for this difference by using our GDP deflator to do so. What I've done here is taken the nominal GDP in 2011 and I'm going to multiply it by a ratio of the price level in 2005 and the price level in 2011. And that price level we're obtaining from the GDP deflator. So the price level in 2005, given the GDP deflator, was our base year of 100. In 2011, it is 113. So when I divide 100 by 113, what it's going to say is that those dollars in 2011 are worth less than they actually appear. And this makes sense because we have prices increasing over time. So when we take this ratio and multiply it by our nominal GDP in 2011, it deflates the total real GDP to 13,357 billion US dollars. And these are real US dollars. And it's not that one is not real or fake or something strange like that, but it's the idea that now we can compare 2005 dollars to 2011 GDP because we're using 2005 price levels. Okay, so now that we have our real GDP figure in 2011 and we have our real GDP figure in 2005, we don't have to adjust this because we're using the year 2005 as our base year, and therefore it's appropriate to make the comparison without adjusting it because 2005 is the base year. You can see that because it's 100 for the GDP deflator. So as we did before, we just want to calculate inflation, so we take the real GDP from 2011 in 2005 dollars, or I should just call them dollars, minus the real GDP in 2005 in 2005 dollars, divided by the real GDP in 2005 in 2005 dollars, times 100 will give us the total GDP growth percentage. 13,357 billion minus 12,623 billion over 12,623 billion times 100. Let's see what that yields us. So we see that there actually was 5.8. Let me check my math on that again. It just seems a little low, but I guess it's pretty accurate. We did go through a recession there without much of a rebound, so I'm assuming that's why it's so low. We had 5.8% growth in GDP between 2005 and 2011. Now, if I were you, I would actually go through and maybe try this for another year. Try it for 2010 and see if you can come up with a good result. And again, maybe you even want to go back to our earlier examples and try different combinations. Instead of looking at the year 2000 versus 1990, look at the year 2015 versus the year 1990. And that might and calculate the index value for 2015 instead of 1990. Just a thought on trying to help you get some more practice in. And feel free to let me know if you come up with answers and have questions about them. So the next thing we're going to talk about, which is actually a pretty straightforward concept, is going to be real versus nominal interest rates. Now, I know GDP growth, real versus nominal, might be a little bit confusing. But again, all we're doing is we are disaggregating price changes from actual productivity growth, right? So as we have positive inflation or increases in prices, we want to be able to see the actual increase in production of goods and services. Is the value adjusted for inflation increasing or decreasing? Are we making more houses, educating more people, building more factories, farming more apples, everything in between, right? But now when we look at interest rates, you guys know what an interest rate is. An interest rate is going to be a form of payment on a lent asset. So I can lend against things which are collateralized, like a car or a home, or I can give you a loan to go to school. And if you are given a loan as the borrower, the lender is going to charge a rate of interest. And that rate of interest is going to compensate them for lending you the funding. Otherwise, they could take that funding and invest it in something else. They could go buy a home and rent it out. They could go buy stocks or bonds, etc., and earn interest income or dividend income or just growth of the asset price on it. Instead, they lend it out to you. So they're compensated, and this would be what the purpose of an interest rate is. So an interest rate is just going to say how much does it cost to borrow for a certain amount of time, or how much are you receiving as the lender over a certain amount of time. And one thing we want to be careful about is, well, are we being compensated adequately given inflation? So when prices are rising year after year and you owe an outstanding amount of money to somebody and they're not getting the money back, well, are they being compensated for that risk? And that would mean that they would have to be earning a positive real interest rate. So the nominal interest rate they're charging you, minus any inflation we're having, they're going to be hoping that there is a positive interest rate that's compensating them for being separated from that money while you are using it for whatever you're using it for and then paying it back. So the real interest rate represents how much an additional buying power a lender or investor receives, or alternatively, how much a borrower or supplier of capital has to really pay. Because if you are paying something just equal to the rate of inflation, then one would hope that your income is going up at the same rate, and therefore you wouldn't really be paying anything for the loan. Let's take a look at this example. How about given current home mortgage rates and given current rates of inflation, do we have a positive real interest rate, or what is the real interest rate? So I looked at home mortgage rates, an average of about 30 mortgages, and this is just something on Google looking at $1,600 a month mortgages, and the average interest rate right now on a 30-year fixed $250,000 mortgage is about 3.17%. So that would be the nominal rate that the borrower is paying to the bank, the lender, on the principal every year. And now, current inflation based on CPI is rather low. We've had energy prices fall dramatically. I think that's explaining a lot of what's driving that CPI, aside from going and looking at the report further. So this 0.7% inflation rate is a year-over-year number, and it's a very low number. I would say normally inflation tends to be in the 2 to 3% range in a developing economy, such as the United States, but we'll just leave it at 0.7 for right now. So what that means is that the lender who's lending you the money, whether they're a bank or whatever sort of organization they are earning 3.01% real interest every year. That means you're paying 3% on your total mortgage or loan in interest for the benefit of being able to own and live in the home. Generally, interest rates are in the 2 to 3%. If interest rates are in the 3% range, then we'd be looking at an interest rate much closer to about 0.7% real interest. So the problem here is that what if interest rates rise? So if interest rates not if interest rates rise, I'm sorry. What if inflation increases? If interest rates rise, this is actually a wonderful thing for someone who has a fixed home loan at 3.71%, because they're going to have a much lower rate of interest than everybody else who's getting new loans. But if inflation increases, say inflation were to go to 4%, say the economy is doing really well, and this is possible that inflation could go to 4%, then what would happen is the real interest rate would actually turn negative. So that would be 4% inflation, and that would give us a negative number. Okay, 0.29%. It's not really so important to just talk too much about what are negative interest rates, but the idea being that if the real interest rate is 0 or less than 0, then the lender is not being compensated for lending you the funding. They won't have any additional buying power and you will not really be paying anything other than the rate of inflation or less than the rate of inflation, which you should be being compensated for in increasing wages year over year, depending on your situation. So this is just a little taste of looking at real and nominal interest rates.